Hello everyone, welcome back to my channel. Let's solve a problem from the 27th Philippine Math Olympiad qualifying stage. This problem belongs to the third part of the questionnaire. This is problem number 6. Consider the equation 3 times the square of floor of x equals x times the floor of x plus 21 times the square of the fractional part of x. The sum of all the solutions to the equation can be written in the form P over Q, where P and Q are relatively prime positive integers. What is the value of P plus Q? Let us start by letting the floor of x be equal to n and the fractional part of x be equal to t for convenience. Now, since the fractional part of x is greater than or equal to 0 but less than 1, it also follows that t is greater than or equal to 0 but less than 1. Now take note that x is the sum of its integer part and its fractional part. So we have x equals the floor of x plus the fractional part of x. Now with this substitution, we have x equals n plus t. Now if we replace the floor of x and the fractional part of x by n and t respectively in the original given equation, we have the new equation 3n squared equals quantity n plus t times n plus 21t squared. Now, if we rearrange the terms, we come up with the equation 21t squared plus nt minus 2n squared equals 0. Now, let us treat this one as a quadratic in t, because if we do this, we can actually create or come up with an equivalent expression to t that contains n. Now, if we can do that, then using this inequality, t greater than or equal to 0 but less than 1, we can determine the possible values of n. So, by using the quadratic formula, we have that t is equal to negative n plus minus 13n over 42. So, there are two possible cases for the values of t. These are t equals 2 over 7n and t equals negative 1/3 n. Now, let's determine the possible values of n for case 1. Since t is greater than or equal to 0 but less than 1, and t is equal to 2 over 7n, it follows that 2 over 7n is greater than or equal to 0 but less than 1. Now, to solve for n, we can just multiply the inequality by 7 over 2 to have n greater than or equal to 0 but less than 7 over 2. Now, remember that n is an integer. So, the possible values of n in this interval are 0, 1, 2, and 3. Now, we can use these values of n to solve for the fractional parts. Using again this one, t equals 2 over 7n, we can solve for t. If n equals 0, then t is equal to 0, right? And take note that x is the sum of n and t. So x here is equal to 0. This is actually obvious in the beginning. It is obvious that x equals 0 is a solution to the given equation. Now, if n equals 1, then t is equal to 2 over 7. And so x is equal to 1 plus 2 over 7, which is equal to 9 over 7. Now, if n is equal to 2, then t is equal to 4 over 7. And so x is equal to 18 over 7. Now, finally, if n is equal to 3, then t is equal to 6 over 7. And so x is equal to 27 over 7. So far, we've found 4 solutions. You can easily check that these 4 work solutions to the given equation. Let us set this aside. Let us have the second case. Again, we know that t t is greater than or equal to 0 but less than 1. So for the second case, it follows that negative 1/3 times n is greater than or equal to 0 but less than 1. Now, in solving this inequality, we have to be careful because the number or the quantity uh, in the middle is negative, right? So, if we multiply the inequality by negative 3 so that it is only n that is retained in the middle, we need to reverse the inequality symbol. So, after multiplying this inequality by negative 3, we must get n greater than negative 3 but less than or equal to 0. Alright, again, n is an integer. So the possible values of n in this interval are negative 2, negative 1, and 0. Again, we can solve for the value of t using the equation t equals negative 1/3 n. Alright, so again, we get x equals 0 if n is equal to 0 as before. Now, if n is equal to negative 1, we have t equals 1/3. Okay, and so x is the sum of negative 1 and 1/3, which gives us negative 2/3. And finally, if n equals negative 2, then t is 2/3, and so x is the sum of negative 2 and 2/3, which is equal to negative 4/3. So we have found two more solutions to the given equation. So all in all, we have six solutions. Now we are told to sum up all the solutions, and the result, according to the problem, is of the form p over q, where p and q are relatively prime positive integers. Alright, so if we sum up all the solutions, we get 40 over 7. And since 40 and 7 are already relatively prime, p must be equal to 40 and q must be equal to 7. And so p plus q is equal to 47. And this is our final answer. If you've learned something from this video, please like and share. Thanks for watching.